everyone. I'm Zhang, Senior Product Line Manager at Cadence. Here I'm at DAC 2024 in San Francisco. I'm going to talk about how to empower AI and data center connectivity with high-speed PAM4 SerDes technology. So first, let's take a look at the drivers behind the demand for high-speed connectivity. Artificial intelligence AI is certainly a big driving factor. To efficiently process the large amount of data required by AI workload, we certainly need not just the computing capability, but also the network bandwidth, and also with the fast-growing demand for AI technology, data center is required to upgrade the interconnect solutions for higher speed, lower latency, and better power efficiency. Along with that, optical connectivity is gaining increasing importance because the copper signaling has its limitations at a higher network speed. So we see high-speed connectivity solutions are gaining more and more importance in all those applications, and other key segments include high-performance computing, 5G communications infrastructure, aerospace, etc. So now let's take a closer look at where in data center architecture the high-speed interconnects are needed. So here is a typical topology for a modern data center. And inside the rack, there are multiple rack units that has CPU, GPU, AI accelerators, link cards inside. And all of them are connected together through the high-speed links. And on top of the rack, that is the top of rack switch, also called leaf switch layers. And on top of that is spine switch. And here we see some very high-speed connectivity happening between spine and leaf. Nowadays, 400G and 800G are deployed, and going to the next generation, it will be 1.6T. So generative AI is a big driving factor, and Bloomberg forecast generative AI-related hardware will grow to 640 billion over the next 10 years. That's a huge growth. So what are the use scenarios for high-speed SerDes, including 224G, 112G, 56G, PAM4 SerDes technology? First, we look at long-reach, LR. Typically, it consists of backplane and copper cable connections between two PCBs that have ASIC on one and another ASIC on the other. And also there's a medium reach application, the so-called chip-to-chip interconnects. The ASICs are sitting on the same PCB board or one on the daughter card. And the next is the chip-to-module, C2M, VSR, very short-reach applications. So the ASIC goes to the front panel, which is the optical module in this case. Usually the module has retimed optics inside, so the connection between ASIC and optical front panel is shorter than the previous two applications, where there are some new trends about to make optical module linear with a direct drive capability or half linear capability. So in those cases, the long-reach SerDes is still needed. There's initiative to move optics closer and closer to the ASIC switch front. There comes the near package optics NPO and co-packaged optics CPO applications. So in general, the high-speed SerDes can be categorized into two types, long-reach and short-reach. For long-reach, it could support LR, MR, and also VSR for different applications. And for short-reach IPs, it has power optimized for VSR, XSR type of interconnections. So we see from this chart published by Cisco, the switch silicon bandwidth doubles about every 2 years. And right now, 51.2T switch is deployed with 512 lanes of 112G SerDes. And going to the next generation, it will be the 102T switch that would need the 200G per lane SerDes technology. In the meanwhile, the Ethernet network speed will grow to 800G or 1.6T. So we see the fast-growing speed need here, and what solutions Cadence provide. Cadence has a very broad high-speed SerDes portfolio. The 224G SerDes was one of the industry's first demos by IP vendors, and it can support long reach, medium reach, and short reach. The silicon performance was excellent, and the interoperability has been demonstrated at different industry events. The 224G SerDes is based in an ADC DSP architecture, which is similar to the architecture we used in our very mature 112G 56G product line. Cadence was the first DSP-based 112G PAM4 SerDes IP vendor in the industry. We have extensive experience to support customer SoC success. So our SerDes solution can support Ethernet with IEEE and OIF compliance, and Cadence also joined Ultra Ethernet Consortium to monitor the progress for the emerging standard, particularly for the AI applications. We also have options to support Ethernet and PCIe multi-protocol. In general, Cadence has a high-speed SerDes solutions that can empower AI and data center applications. So Cadence provides the integrated subsystem to our customers, not just the PHY, but also the controller. Our subsystems are fully verified and can support up to 800G or 1.6T. We also support our customers on system design, SoC design, provide a very comprehensive integration guide and package and board reference design to our customers. Our SerDes solution has industry-leading performance, power, and area, PPA. It's a very mature solution. So here shows the architecture diagram of our high-speed SerDes. It's an ADC DSP-based architecture. And for the DSP part, it has advanced DSP engine, including FFE, GFE for equalization, and MLSD, maximum likelihood sequence detector, to maximize the performance margin. They can support ultra-long reach, 45 dB insertion loss, beyond the standard requirement. So regarding the integrated subsystem solution, here is a diagram showing how it works. So controller IP includes MAC and PCS, FAT, and PHY IP includes the SerDes, RX, TX, and the PL and common blocks. So we see multiple lanes of the PHY SerDes can be collected to MAC PCS with single Ethernet port or channelized multi-Ethernet port. So Cadence has demonstrated our 224G and 112G SerDes solutions at many industry events, and we produced the videos at Cadence website and YouTube.com showing our excellent silicon performance. In summary, we talk about the rapid growth of high-speed links driven by AI, data center optics, HPC, and many industry segments. Cadence has industry-leading 224G, 112G, 56G, PHY, and controller IP solutions to provide the fully verified subsystem to our customers. And we have both long reach and short reach in our portfolio to meet different market demands. And we have demonstrated excellent silicon performance for our 224G, 112G, and 56G SerDes, and they are proven in Cadence test chips as well as customer SoC production chips. To know more information about our high-speed SerDes solutions, please visit Cadence.com. Thank you.